All right, again, we're looking at a particular question that asks us to think about the relative strengths of a couple of species when it comes to acid strength. So it asks us in this case to actually rank them, and we can do that. We can certainly pick the strongest acid, and then we'll just go on and have a little bit of order when it comes to the other three species once we figure out which one is the strongest. So remember, in order to figure out acid strength, we need to consider the relative stability of the conjugate bases. The more stable the conjugate base, the stronger the conjugate acid is. And so that's what we need to do. We need to draw all of the conjugate bases. So as I draw the conjugate bases out, I'm talking about individual protons that are getting donated when these species act as acid. So proton donors are acids in the Bronsted-Lowry acid-base definition. So if I want to consider all the factors that make up my acid strength consideration, I would think about the atom that the hydrogens are connected to. But in this case, I see that they're all connected to oxygens. So that's not going to be a factor. The next consideration is resonance. And if I look at them, and I'm only going to show in this one, they all have this ability to form resonance contributors. So, and they all form resonance contributors in exactly the same way. So that's not the consideration either. And they're essentially all carboxylic acids. So that's not what's going on here. But the next consideration is induction. And induction is the presence of more electronegative atoms near the site of the negative charge. And so when an electronegative atom is near that site, it pulls electron density away from the negative charge, and that's a stabilizing effect. So the closer the electronegative group is to the negative charge, the stronger the induction effect, and the stronger the induction effect, the more stabilizing that is. And so let's take a look. We've got electronegative groups, bromines. So the question we want to ask ourselves about these bromines is where are they located? And the only thing is, well, the only difference is how many there are and where they're located. And so in this case, I have one bromine, and it's as far away from the negative charge as it could possibly be. It is, let's count the number of places removed it is. It is 1, 2, 3 carbons removed. Now, the same is true for this one, 1, 2, 3 carbons removed, but instead of having one bromine, I've got 2. So that induction effect is going to be larger for 1 or for 2 than it is for 1. Now let's take a look at the next two. I also have 2 bromines as giving me inductive effects. In this case, it's 1, 2 away. And in this case, I have one that's 1, 2 away and another one that's 3 carbons away. So they both have 2, but for 3, they're closer. They're just closer to the negative charge. So that inductive effect is stronger. So that means that 3 is the strongest acid, and 4 is the next strongest acid. 2 is the next strongest acid after that, and 1 is the weakest acid. So it turns out they were almost in order with 3 and 4 swapped. 3 is the strongest acid. Okay, that's all there is to that.